Yeah. Hi, thanks for inviting me to be here today. My name is Amr. I'm one of the founders of Vectara, and I'm also serve as the CEO for the company right now. And I will tell you about Vectara later on, but I'm going to start by hopefully teaching you something new that I assume, given the crowd here, many of you would know about this already. But I'm going to talk about this topic of the difference between what's known as LLM fine-tuning versus retrieval augmented generation. And I'm going to make this very bold claim right now is LLM fine-tuning, meaning teaching an LLM to speak your own data, is not going to work. And you have to look at something else. And this is really the core concept behind this talk and actually behind our company. So to describe why that is the case, we have to go over why. What's the problems with LLM fine-tuning? So that's what I'm going to describe right now. First, what is LLM fine-tuning? LLM fine-tuning is about taking an existing LLM, that could be ChatGPT, that could be Llama. That LLM has been trained on publicly available data, on copyrighted data, etc., etc. But now you want that LLM to speak your own data. You want to speak with, to know things about your company, about your documents, about your information. So that's when you do fine-tuning, which is a fancy way of saying incremental training. You're really doing incremental training. You're taking an existingly trained LLM, you're giving it further data that is your data, and this data now gets compressed into the weights of this new derivative model. So that new derivative model has your data, so that's your data now, except your data is not stored verbatim as is. This is the learned version of your data in the weights. The original copyrighted information will still be there, and the public domain works that were used to train the model will still be there. So this is how fine-tuning works. So what's the problems with it? There's many problems. I'm going to go over all of them right now. The first one is this process of doing incremental fine-tuning. Not only is it slow, meaning new data coming in might not materialize itself in the output until hours, if not days later, it's also very, very expensive. Fine-tuning is a very expensive process. So that's the number one problem, speed and cost. That's the least of the problems, though. the most common problem that I'm sure many of you heard about is hallucinations. Hallucinations is the model making up information which is not in the original data. And the reason why large language models do that and will continue to do that unless we significantly change them is because they are doing lossy compression. What large language models are doing is they're taking all of this data they have been trained on and then compressing it down with ratios from anywhere to 1 to 1,000 to 1 to 1 million compression rates, right? So by definition, they don't have the original data anymore. They have a distilled down, compressed representation of that data. And that's why sometimes when we ask them questions, they make up stuff because they don't know what was the origin. They're just trying their best given the compression they have went through. So anyway, the summary is, if you're using this in a business context, you cannot have hallucinations. I'm sure many of you heard about the lawyer that got disbarred because he created a case that he deployed with a judge, and the judge looked and many of the citations in there were made up, were completely made up by the large language model. So you need a way to eliminate hallucinations if you're going to use this in a business context. Second, if you're going to use this in a regulated industry like finance or medicine or accounting or legal, you need to be able to provide explainability. You need to explain the output. You cannot just say, here is the output. You need to say, how did you drive this output? What factual documents, what factual information was behind the sentences in the output that you are providing so that we can trust that output. That number one, is not hallucinated, and number two, the logic behind it is clear. So explainability and citations is a very big problem with large language models right now. Next is very hard to enforce access control. So imagine the question coming from the CEO versus the question coming from some individual who only is allowed to see a fraction of the data that the model knows about. If that data already has been trained inside of the model, there's no way to enforce that access control. The only way to enforce it is to say only the CEO can ask the questions because the model knows everything. So enforcing access control on the known facts in the model is impossible today with this technique. Next, maintainability. How are you going to update and delete this information? If you had new data coming in and you train the model, the data is inside the weights of the model. Now you want to go and delete that document, you have to retrain. You want to update that document, you have to retrain. So maintaining the model with factual information as it's changing is extremely hard to do within the fine-tuning world. Next, if you are going to use this in a business context, most businesses cannot allow copyrighted information that they don't own the rights to make it out as part of the output. You need to suppress copyrighted works and bias as well, which might exist from being manifested in the output. With large language models, unless you knew what they were trained on, and unless you did alignment or did your own RLHF or did your own training that suppressed the copyrighted information, all of it, you cannot guarantee that it's not going to make itself in the output, which is a very big concern. Same thing with bias. If the model was trained in a biased way and you further train it with your data, that bias will be retained in the training. It's hard to eliminate the bias if it was already in there. It's not impossible. It's really hard for the average organization to do that. And hopefully this is not a problem. There's one more problem, is what if the model itself, actually a couple more problems, and then I'll end the problem list. What if the model itself is upgraded? There's a new version of Llama v3, and you want to use Llama v3 now with your data. What do you have to do? You have to go all the way back to here. You cannot just swap in Llama v3 and be up and running with Llama v3. No, you have to go back to Llama v3. You have to retrain everything with your data on top of the Llama v3 weights to get Llama v3 updated that can speak about your data. So maintaining as the models get upgraded is extremely hard. Last but not least, when you're training these models, your data, even though it doesn't exist there as is, like it's wrong to say new data because this is not your data anymore. This is the compressed numerical representation of your data. It's in there in the model's brain. So you will have companies like OpenAI or many others that will tell you, oh, we never look at your data. We never look at your data. We never look at your queries. They're encrypted. They're all yours. They're right, actually, when they say that. However, the learnings from the data, which is in the weights inside of the model, are in a gray area right now. They're a gray area. They're similar to us. If you go to a university or go to a company like Explain, you're working here, and you learn so many things while working at Explain, but you don't copy any of the documents, but you have a very good memory. It's in there. It's in your memory. The weights are in your memory, right? But if you have a copy of the documents in your hard disk, you can be sued. But if you have the weights inside of here, it's much, much harder. And the same complexity exists with this. And this is one of the reasons why open source is doing so well right now, because the organizations that want to leverage these models are very worried about training a model that some other company owns on their own data. Because what if now that becomes part of the AGI they built that competes with them in the future? So these are all the problems with the fine-tuning. To summarize them, costly and slow, hallucinations will still occur, very hard to explain the output, very hard to suppress copyrighted information, very hard to reduce bias. The weights in the large language model know your data. It's hard to enforce access control. It's hard to delete and update the knowledge inside of the large language model to maintain it. So what's the benefit of it? The only reason why you would want to do fine-tuning, in my opinion, is if you want to teach the model new styles or new techniques of doing things, new methods, not new information, not new data. If you want to teach it a new language that it doesn't know, if you want to teach it a new style of writing, like one of the people in your company, Hassan, is the best English writer there is, and we want the model to write English in the style of Hassan, then you would do fine-tuning. This is a good area to do fine-tuning. A style of coding inside of the company that you want the style of coding itself to manifest, then you do fine-tuning. But if it's simply about repeating back information and knowledge, this is the wrong approach. And our approach, of course, is the right approach, which is the one I'm going to talk about next. But there is a quick question.
Are you talking about finding similar data that was already trained with large language models?
I'm talking about fine-tuning with your own company data. So you're a law firm, and you have lots of legal documents that you, contracts that you worked on, briefs, case briefs, and that you have, that you want to be part of the information and responses being given back to you. The large language model already knows the law. It already passes the bar exam. It doesn't need to learn your data. to come up with new legal conclusions. But it needs to know your data to be able to give you back a response, which is a function of your data. Yeah.
How that's different from fine tuning? You say
yes. So I'm going to talk about that right now. So to be more clear, what we are doing here with this new way of doing things. So the new way of doing things. Okay, Osama, quick question. Go ahead.
All right. I mean, because it's so expensive today, when I go to fine tune ChatGPT or whatever, I pay them money for it, but they're not retraining the whole model.
Yes.
They're doing what's called adaptive.
Yes.
Right.
Yeah.
Which is take out.
You're doing a patch. You're doing a patch of the weights
exactly.
on top of the original
remove
weights.
the top layer and you train a special small element, which doesn't suffer a lot of these problems.
No, it does.
Okay.
Yeah. So we can have that conversation.
Right.
Yeah. It's a bit more technical, but we can and we should have it. So the approach to solve this problem is what we refer to as, and what the industry, not just us, Vectara, a number of other, the industry is waking up that they need this. Like big companies are starting, Microsoft is starting to do this, Google is starting to do this. Everybody sees that this is the way to go. It's not the fine-tuning way, it is this way. It's called retrieval augmented generation, or you'll also hear it referred to as grounded generation, which you want to generate an output, but that output is grounded in the facts. And to do that, you need two large language models. You need a retrieval large language model, and you need a generative large language model. So this is the key. This is the secret for how you do this. You have one large language model over here with the job of only one job only, which is given a prompt and given a question, what is the most relevant facts in the customer data that can address that question? And that's it. That's all it does. And then you still have the generative model. The generative model, its job is to produce outputs that we humans can read and understand in a coherent way. So in this picture, what will happen is when the question comes from the end user, that question will go here first. We very quickly find the most relevant facts in the underlying data, and then we give these facts to the generative model, and we tell the generative model, dear generative model, we would like you to leverage your knowledge of the English language, the Chinese language, the Arabic language. We would like you to leverage your knowledge of the law and how the law works, engineering and how engineering works, medicine and how medicine works. However, this response you're going to give me, ground yourself, restrict yourself, sandbox yourself, not introduce new knowledge from here, only leverage these facts that I'm providing to you. And by doing that, you solve all of the problems I highlighted earlier, which I'm going to show you in a demo right now. And that's going to be the end of my talk. Yes, good question. Excellent question. So the question is, but wouldn't you have a problem that you have to retrieve this model over and over again? If you were doing it with the standard techniques, yes. But the way we build this model is with an approach that's called zero-shot training. So zero-shot training means that you train the model on the domains. When the customer data comes in, you don't need to retrain the model. You can inference right away, and it will still inference correctly, even though it has never seen that customer data before. And you can do this zero shot on this side. It's very hard to do zero shot on this side, but you can do zero shot on this side. So that's the solution. So in fact, we don't train on the customer data at all. The customer data is simply going through the model, is being indexed. The model now retrieves back the vectors that must match the question or prompt, which we then feed to the next model. And I can give you a more detailed answer during the break. Here, yeah, you still do prompt engineering. Yes, we're doing real-time prompt engineering. So this is kind of what we're doing for the second model, right? So the first model is giving us the facts. We take these facts, we assemble them into a very smart prompt that we give to the second model to generate the output. And this is roughly what the prompt is. This is not exactly what it is, but it's roughly what it is, right? It's saying, you are a search bot that takes facts, results, and summarizes these as a coherent answer. That's your job. That's what you're supposed to do. You must only use the information provided in the facts. Don't go make up shit from the outside world. You must cite the facts you're using. So every time you use a fact, cite that fact in your outputs. You should only cite the most relevant fact. If it's a fact, and each fact has a relevant score. If the relevant score is too low, don't include that citation in the output. And most importantly, if all the facts are of low relevance and not useful, just say, I don't know. Like, it's okay to say, I don't know. Don't go make up something. Don't hallucinate an answer. So that's the prompt.
You engineer prompts based on the interface data.
Yes.
And then you feed it.
Yes. That's the summary. You nailed it. That's the summary of the talk right there.
Great stuff.
Thank you.
I've always seen RAG as an external data as opposed to a model. Is this standard RAG? Wouldn't that be easier to update the new facts if they come in as a training model?
Yes. But here is the point. There's two ways to do the R in the RAG: the old way and the new way. The old way to do the R in the RAG, the retrieval, is keyword search. Is you're matching based on keywords, right? That was the old way, and that's the old way that people were thinking. And that fails completely in this new world, which is based on comprehension and understanding. So in this new world, what you have is a model that knows how to map our words, English, Arabic, Chinese, from language space into a universal meaning space across all these languages. It's retaining the meaning, and we call these vectors. If you hear the word vector, a vector is a pointing in that meaning space to the meaning of these words. You also hear the term embedding used for that as well. So you need to have a very good model. We have the best. We just launched updated benchmark results last week, actually. We beat OpenAI, we beat Cohere, that knows how to do that, and knows how to do that across many languages at the same time. So if you say weather balloon in English, or say weather balloon in French, or say weather balloon in Arabic, they will all map the same vector in that meaning space. So that's what the model does. It does this mapping, and then vector matching finds the best meanings that match what the user is after, instead of keyword matching, which was our hack as humans until we figured out a better way to do it. Okay. So I really want to show the demo. I see many questions. We're going to be here during the social section, so I'm going to be able to answer all of them, but I really want to show the demo, which will take only about a minute. So let me show that, and then please come in the break and ask me as many questions as you would like. So this demo is called Ask News. And what Ask News is doing here is it's indexing data from BBC, NPR, Fox, CNBC, and a number of news sources, as you can see up here. And I'm going to ask a question like this: should AI be regulated? And what's happening right now is we're very quickly retrieving the facts. This is the fact retrieval by the first model. And then once you finish retrieving the facts by the first model, you get the response summarized for you. And you can see the response now that is coming back for that question that you asked includes citations for every sentence, so you can track it back lineage-wise to which documents support this conclusion that you have in there. You can see it's not biased, because we make sure also as part of the retrieval, we're not just retrieving the most relevant fact, we're retrieving a diversity of facts around what you're looking for. That's how you minimize bias. So that's why it starts by saying it's a topic of debate, because I'm seeing in the results, I'm seeing people say, yes, it should be. I'm seeing people saying, no, it should not be. So if I look at review results here, you will see the underlying documents, and you will see the documents will have the different perspectives being covered in there. And that's how the model stays unbiased in its conclusion. Another important thing is this response and these results are not being retrieved based on keyword matching. I'm not matching the keyword regulated. I'm not matching the keyword AI. I'm matching the meaning behind these words. That's really the hard part to get this done right. So if I have said this instead, I could have said, should intelligence created by computers, which is another way of saying AI, be controlled by the government, which is another way of saying regulated, it will still match correctly. But here's the magic: even if I do it in a different language, it will still match correctly. So I'm going to go here, and I'm translated this using Google Translate from English to Arabic. I know there are a few of us here in this room that speak Arabic. هل ينبغي تنظيم الذكاء الاصطناعي? And I'm going to take that, which is an Arabic string. It's a bunch of Arabic keywords. We're not doing translation. We're not translating this to English first and matching. This is the neural network itself. It doesn't care what language we speak. It doesn't care what language the underlying documents are in. I mean, the documents here happen to be all in English. That's the source language. But these documents that we have in could have been French, Chinese, Japanese. It doesn't matter. We'll find the most relevant facts, regardless of language. And then we give you back, you feeble human, because you only speak Arabic, we give you back the response in the language that you can understand. And then the last part is I want to show that we don't hallucinate. So I'm going to put a query here. What did Hassan Sawaf invent lately? And in other systems, as you know, the answer might come back, he invented the microscope or invented the rocket or whatever. But here, because none of the underlying facts were of high relevance enough, we just say we don't know. The engine responds back and says that the return results did not contain sufficient information to be summarized into a useful answer for your query. And that's it. Thank you very much. So questions, we'll take them in the break. I'm sorry, they gave me a bunch of signals. Yeah, thank you.
Thank you. Thank you, Amr. It was very insightful.